this video is going to be about changes of matter. So let's get started. I'll share my screen with you. So here we are, and all of these pictures now should make sense to you in terms of what we've been talking about in the last couple of lessons. And we're doing the final lesson in this unit on the introduction to matter. So we'll be talking about the bottom right corner pictures. I'm going to minimize myself and move myself up here so you can see the full screen. And here we go. So we're talking about the same essential question: how can we observe, measure, and use matter? So these are our science standards. Again, we're talking about asking questions, defining problems, developing and using models, planning and carrying out investigations. I will post this presentation after the video as well so that you can relook at the science standards at your leisure and all of the content, because there's a lot of content in today's lesson. And then this is our substandard for science: analyze and interpret data on the properties of substances before and after the substances interact to determine if a chemical reaction has occurred. And we will be talking about chemical reactions today. We do have some lab work we would like to do with this lesson as well. For those of you that are virtual only, we will be recording those so that you can observe what we are doing in the lab. Here are our objectives today, and as you know by now, the objectives will turn into questions at the end of the video that you will be submitting the answers to for me as an assignment. So pay attention to the objectives as we go through the lesson. I can define and explain the 2 types of changes to matter. I can explain 6 types of physical changes to matter and give an example of each type of change. And by the way, all of the information for these questions are going to be in the video and in the presentation. Number 3, I can explain 5 types of chemical changes to matter and give an example of each type of change. I can list at least 6 differences between a physical and a chemical change. I can explain the law of conservation of mass and give one example of this law in real life. I can explain what happens to energy in a physical or chemical change. I can explain the difference between temperature and thermal energy. I can describe what 2 possible things happen to thermal energy during a chemical matter change. And I can explain where energy is stored in atoms. So these are the things you should be listening for during the video. Okay, do you remember what matter is? Yes, matter is anything that has mass and takes up space. It needs both qualifications, right? Has to have mass, has to take up space. Matter can change from one state to another. So there's actually 4 states of matter. There's very many more, but that's for higher level science than what you guys are doing in middle school. But we'll talk about solid, liquid, gas, and plasma in future lessons. But just know that there are 4 states that we are going to talk about in middle school science. What are the 2 properties of matter? Well, there's the physical property, which we've talked about in our lesson 1. If you want to go back and rewatch that video, feel free to do so. Physical property is a characteristic that can be observed without changing the matter into another type of matter. So what can we observe? Well, we can see something like a color. We could hear it. We could feel it, right? It might feel slimy, or it might feel hard, or it might feel soft. We could touch it, same thing as feel. We could smell it. It might have an odor. We could measure it. We would measure it mainly by its mass. The other property is the chemical property, a characteristic that describes something's ability to become something else. So there's a comparison of physical properties versus chemical properties. So some chemical properties would be flammability, corrosiveness, that's its ability to rust or not, combustibility, and its pH level. And then you can see the physical properties there as well. Those are just some of both. That's not all. Can matter undergo changes in physical or chemical properties? Well, matter can change physically or matter can change chemically. Any kind of change in matter involves a change in energy. So keep that in mind. To bend and change this bar here, Muscle Man needs to use his energy. He's using mechanical energy that is bending that bar, and the energy is initially coming from chemical energy in the food that he eats that is being fed to his muscles to make him bend that bar. And you can also see that a pot of boiling water requires heat energy from the stove, right, in order for it to turn into a gas. And we'll be talking more about this idea later. What is a physical change? We'll start with that. So a physical change to matter alters the form or appearance of the matter, but it does not turn that matter into a different substance. It does not deal with the molecular level of a substance. It only deals with the outward appearance. So matter that undergoes a physical change is still the same substance after the change. That's important. It's still the same substance. So this glass here may be broken, but it is still glass, and it has the same chemical composition, just in smaller pieces. It's still the same glass, it's just broken smaller. So that's an example of a physical change. What are the types of physical changes? Well, here we go. There's the changes of state. So changing from a solid to a liquid to a gas to a plasma. Those are changes of state. That's a physical change. That is not a chemical change. Changing from a solid to a liquid and or to a gas and or to the plasma are physical changes. When ice melts, it goes from being a solid to a liquid. It is still water, the same substance. It has not changed what's inside of it. It's still water. It's still H2O, 2 atoms of hydrogen, 1 atom of oxygen. Slicing a lemon. It is still a lemon after you slice it. It's the same substance, right? It's still the same lemon. It's just smaller pieces. So changes of state are physical changes. Another type of physical change would be dissolving. A lot of people get this one mixed up. They think dissolving is a chemical change. Dissolving is a physical change. When you dissolve one substance into another substance, it does not make a new substance with new properties. Each substance still has the same properties before and after. So for example, mixing sugar into water dissolves the sugar in the water, right? It's dissolved in there. However, you can boil away the water, and then when you do so, what'll be left will be a crust of sugar on the bottom of the pan, right? The sugar and water have kept their same properties. The water is now a gas. It's still water, however, and the sugar is still sugar. It still will have the taste of sweetness, and it will still be grainy feeling. So it has not changed at the molecular level. So dissolving is a physical change. Another one is bending. Bending is a physical change. Here is a muscle man bending a bar. The bar bending is just changing its shape, but it's still the same bar. It has not changed into something chemically different. Crushing is also a physical change. Crushing changes the form of these candles. Watch them being changed there, but they are still the same candle wax. That's cool, isn't it? Yes, they are still the same. Okay, what else? How about breaking? We talked about broken glass and how that's the same. That's a physical change. Breaking makes more pieces of the matter, but it is still the same matter. That brick is still the same. I don't know if that guy's hand is the same after that, but I think it probably is. He knows what he's doing. Carving is also a physical change. Carving makes more pieces of the same matter, but the matter's properties remain the same. That meat is the same. It will taste the same whether it's a big hunk or it's a small, tiny piece. What changes with a physical change? Well, we talked about it. Any change that alters only the shape or form of matter is a physical change. Always pay close attention to the yellow boxes. Those are key ideas I want you to get out of the presentation. So shape or form, if that changes, it's a physical change. Methods of separating mixtures such as filtration and distillation are only physical separations, right? Because they are physical changes, not chemical. Okay, on to a chemical change. What is it? Well, a chemical change to matter produces one or more new substances with new properties. Another term for a chemical change is a chemical reaction. So some chemical changes there on the right. A rotting banana is changing chemically. It's going to start stinking eventually. Burning wood is changing chemically. Mixing vinegar and baking soda, we're going to talk about that a little later. And fireworks, we'll be talking about all of these, not the rotting banana, but that is also a chemical change. What are the types of chemical changes? Just like physical changes, there are different types. Now we're going to talk about the chemical changes. So decomposition chemical change is the first one. In some chemical changes, a single substance breaks down into two or more substances. Hydrogen peroxide, when poured on a cut, breaks down into water and oxygen gas. So it's one substance to begin with, becomes two completely different substances after the chemical reaction. And those two substances have different properties. That's the decomposition chemical change. The next one will be the combination chemical change. In other chemical changes, two or more substances combine to form different substances. So with the hydrogen peroxide, we had one substance splitting apart, so to speak, and now we have two substances combining to make different substances. So here's an example, photosynthesis. It uses sunlight, water, and carbon dioxide combined, and when it mixes it all together, it creates a chemical reaction to produce oxygen and plant sugars. So you see on the left there, the stuff that goes into the plant. You see on the right, the stuff that comes out, the oxygen and the sugars. That is a combination chemical change or chemical reaction. The next one is a single replacement chemical change. One element is substituted for another element in a compound, and that generates a new element and a new compound as products. Let's see what happens. So for example, rust. The iron reacts with water and oxygen to form one new substance, hydrated iron oxide, which is also known as rust. That is a single replacement chemical change. The next one is a double replacement chemical change. This consists of two ionic compounds, one with a positive charge and one with a negative charge. And then the charges switch places during the chemical reaction and two different compounds are formed. So here's your baking soda and vinegar. The chemical reaction of vinegar and baking soda has two compounds. They recombine to form two new compounds. So once they're combined, they form carbon dioxide gas and water. That's a double replacement chemical change. Okay, then there's the final one, the combustion chemical change. A chemical change in which a substance reacts with oxygen gas, releasing energy in the form of light and heat. Combustion reactions must involve O2. So fireworks utilize a combustion reaction. They react with oxygen to release the beautiful colors we see on the 4th of July. That is a combustion reaction. It always forms heat and light. That's the key for that one. Moving on. Can you identify the type of chemical change? When you burn something, it reacts with oxygen in the air to create ash and smoke and energy in the form of light and heat. This is a permanent change that cannot be undone. You cannot turn ashes back into the original object. That's a key to knowing it's a chemical change. And then which of the 5 types of chemical changes is burning considered? Of those 5 types we just talked about, which one do you think it is? It's producing heat and light, so it must be, burning is combustion, right? It's combustion chemical change. Okay, now we're going to decide here. Well, first we're going to come up with an analogy of how physical and chemical changes compare. So let's take the words Dear Mom. I can make the letters bigger or change the color, right? Here I have the words Dear Mom bigger and I have changed them to blue, right? Or I can rearrange the letters and I can make a different word or two different words. Arm mode. Arm mode means something different than Dear Mom. So what is a physical change to Dear Mom? Well, the physical change is making the letters bigger or making them a different color, right? That's changing their appearance only. The chemical change could be likened to rearranging the letters to make an entirely new message. It's kind of what happens in a chemical reaction. The molecules rearrange and attach in different ways and make an entirely new substance. How can you know when I combine a substance if I've made a physical or a chemical change? A chemical change will always result in one or more new substances that cannot return to its original substance. So there's a picture of ice. That's a physical change. Water into ice, same substance. That is a chemical change. Water into hydrogen peroxide. The molecular level has changed. A physical change is only a change in how something appears or a change in its shape. The substance retains its same beginning properties like density, boiling point, color, etc. Okay, now we're going to do a little bit of a comparison sort. So we have physical change on one side and chemical change on the other. Okay, the substances at the beginning are the same before and after the change. What side does that belong on? Physical change or chemical change? I hope you said physical change. Good for you. Next one. The substances present at the beginning are not present at the end. Which change, physical or chemical? I hope that you said chemical, right? Because you get a whole different substance after a chemical change. Try this one. The composition of matter always changes. Composition of matter always changes. That's the mixture, the amount of different types of atoms. Right, that is a chemical change. Composition is the makeup of something. Next one. The composition of matter does not change. There is no molecular change. I hope you said physical for that. There we go. What's the next one? It can be undone. Which one can be undone? A physical change or a chemical change? Right, I hope you said physical. A physical change can be undone. It cannot be undone. Well, what do you think that one has to be? Right, that's a chemical change that cannot be undone. Involves a change to molecules. A change to molecules. Yes, chemical change. Remember, at the molecular level is a chemical change. Involves a change to outward appearance. Exactly, physical change. Next, melting an ice cube. Don't get this one wrong. Exactly, it's a physical change. Changes of state are physical changes. Gas bubbles appear. That is a chemical change. Tarnishing, it's kind of like rusting in a sense, only it's with silver. Yes, that's a chemical change. Next, cooking an egg. Physical change or chemical change? Well, that is a chemical change because the egg does not retain its same properties after it's cooked, does it? No, it does not. So it's a chemical change. Mixing salt and water. Don't get this one wrong. Mixing salt and water. That is a physical change because it's a solution, it's dissolving, it's not chemically bonding in any way, shape, or form. An object catches on fire. Can that return to its original state after it burns? No, it has to be a chemical change. What about includes words like tearing, melting, and breaking? Tearing, melting, and breaking. Right, physical change. Includes words like burning, rusting, and oxidizing. Definitely a chemical change. I think that was our last one. So this would be good to remember. It's one of your questions on your objectives. Okay, what is the law of conservation of mass? You need to know this. When a piece of paper burns, it may seem to lose mass or disappear. It looks to you, and in this picture, like the paper is getting smaller and smaller, so the mass is going away, right? False. There was a chemist named Antoine Lavoisier, and he proved this idea false when he measured mass before and after a chemical change. He found that no mass was lost or gained during the change. So here's your important law of conservation of mass. It states that matter is not created or destroyed in any chemical or physical change. Matter is not created or destroyed. Sometimes this law is called the law of conservation of matter because mass is a measurement of matter. So you might hear it's called the law of conservation of mass, or you might hear it called the law of conservation of matter. Same law. An example of the law of conservation of mass. Well, a common chemical change is the burning of natural gas on a gas stove. So if you have a gas stove, you've probably seen this flame before. Natural gas is made up mostly of a compound called methane. The chemical formula for methane is 1 atom of carbon, 4 atoms of hydrogen bonded together. When methane burns, it combines with oxygen in the air, and an exothermic combustion chemical reaction occurs. We'll talk about exothermic in a little bit, but know that a combustion, that's the type of chemical reaction. Remember, we said combustion always involved heat and light. So there's your heat and light. And combustion reactions can always have to occur with oxygen. So that's a way to know the type of chemical reaction you're dealing with. 2 new substances are formed when you have this methane gas. You have carbon dioxide formed and you have water vapor, which is H2O, right? So both carbon dioxide and water have different properties from methane. They're not the same properties as they started out. It is a chemical change. So let's take a look at how this works with the law of conservation of mass. So here is your methane molecule. It's 1 carbon atom, 4 hydrogen bonded together. Plus, we're going to add 4 oxygen, or 2 oxygen molecules. Oxygen O2 is a combination of 2 oxygen molecules and then 2 more. And then that's going to result in carbon dioxide. When the methane reacts with the oxygen in the air from when you turn on the gas stove, you get carbon dioxide out, a molecule of that, and you get 2 molecules of, water, H2O. Isn't that interesting? So that's a chemical formula. Now, how does the law of conservation of mass work with this? Well, let's take a look. How many carbon atoms before the reaction? So before to the left of the red arrow is your before. So this is your before the chemical reaction. This is your after the chemical reaction. I'll bring up my spotlight. Before the chemical reaction, after the chemical reaction. Okay. So how many carbon atoms before the reaction? Well, I only see my spotlight out again. I only see this 1, right? So there should be 1. Okay. How many carbon atoms after the reaction? Well, I still only see 1, right? Okay, so there's 1. How many oxygen atoms before the reaction? Well, there's 1, 2, 3, and 4, right? So how many? 4. And how many oxygen atoms after the reaction? Well, let's count. 1, 2, even though they're combined differently, right? 3, 4 combined differently, there's still 4 oxygen atoms. How many hydrogen atoms before the reaction? 1, 2, 3, 4. So there's 4. And how many hydrogen atoms after the reaction? Let's find them. 1, 2, 3, 4. Combined differently, but there's still 4, right? So what does that tell us? That's an example of the law of conservation of mass. The methane combustion reaction does not result in any gain or loss of mass. All atoms that go into the reaction are present at the end of the reaction. They have been moved around in different ways to make different substances, but they are still all there. So that's an example of the law of conservation of mass. Remember this? Any kind of change in matter involves a change in energy. Remember we talked about that? And we now know that any change in matter does not create or destroy new matter based on the law of conservation of mass. However, what happens to the energy in a physical or chemical change? Does that energy change? Does more energy go one place and then something else loses energy, like the pot, for example? Are we losing any energy there? What's happening? Well, let's take a look. Does energy change during a physical or chemical change? Energy is also conserved in a physical or chemical change. Energy is never created or destroyed, it is only transformed, just like the law of conservation of mass. Same thing with energy. It is not created or destroyed, it's only transformed into something else. So here's some transformations. So you bite into this apple. Here, let me get my spotlight. You bite into the apple. That gives you energy, chemical energy that is transferred into mechanical energy as you bike and use your legs and your muscles. Here's chemical energy in a battery that is transformed into light energy in a flashlight. Here you have electrical energy in a plug, transforms into light energy in the lamp. Here you have chemical energy in the key, I think, the ignition, changes to mechanical energy as the car drives down the street. Here you have light energy, and then that makes photosynthesis a chemical energy. Here you have an electrical plug, which plugs the toaster in and causes heat, which is a change of energy, right? Transformation of energy. What is the difference between temperature and thermal energy? Kids get this mixed up. Temperature is how hot or cold something feels. If you come inside from a cold outside winter day and you come into the warm house, right, you're going to feel a lot warmer inside than you did outside. That's a temperature feel. The particles in a cold gas, in our case, the cold air outside, will have less average energy of motion than the particles in a hot gas inside, right? Like the air inside the house. Temperature measures average kinetic energy. Kinetic energy is motion energy. We'll be talking about that in the second half of the year. But temperature is measuring average motion energy. So what is the difference between temperature then and thermal energy? Thermal's got kind of the sound of a thermos in it. So it has to do with temperature in a way, right? It has to do with heat. How much energy flows from one object to another is thermal energy. Thermal energy is heat, not temperature. Thermal energy measures total kinetic energy of all molecules within it. So it's not measuring an average kinetic energy, it's measuring a total kinetic energy. Talk a little bit more about that later in the year. So what happens to thermal energy in a change of matter? When matter changes, one of two things happens to its thermal energy. Number one, you can have an exothermic change. This is one in which energy is released. Using your gas, your methane stove is a release of thermal energy. You can have an endothermic change. That's energy that is absorbed. Ice absorbs thermal energy from the air around it, leaving the air around it feeling cooler. That's why we put ice in a cooler, because it keeps things cold. Keeps the air around it colder, right? As it is absorbing the thermal energy and taking away the heat that is in the air. What or where is chemical energy stored? Well, chemical energy is stored in the chemical bonds between atoms. There are some examples of some chemical bonds: ionic, covalent, metallic. Foods, fuels, and your cells will store chemicals. Burning fuels transforms chemical energy and releases some of it as thermal energy. Remember, energy is not created or destroyed, it's only transformed, correct? So bike riding equals chemical energy from the food the person eats, which equals mechanical energy of your legs, muscles, as you bike up the hill. Okay, your homework then is going to be answering these questions. And like I stated, I will be sharing this slide deck with you as well. So you're going to define and explain the 2 types of changes to matter. You're going to explain 6 types of physical changes to matter and give an example of each type of change. You're going to explain 5 types of chemical changes to matter and give an example of each type of change. You're going to list at least 6 differences between a physical and a chemical change. If you want to list 7, feel free to do that. You can explain the law of conservation of mass and be able to give 1 example of this law in real life. You don't have to use the one I used in the video here, but you can. It's up to you. You can explain what happens to energy in a physical or chemical change. You can explain the difference between temperature and thermal energy. You can describe what 2 possible things happen to thermal energy during a chemical matter change and explain where energy is stored in atoms. So that ends our video for today. So I will see you in the next video and I hope you're having a great day. Bye.